compare the energy of compare the energies of two radiations whose wavelengths are compare the energies of two radiations whose wavelengths are 600 nanometer and 200 nanometer respectively. Okay? Now let's look at the question. They are asking us to compare the energies of the two radiations whose wavelengths are this much. Okay? So we have two radiations of two different wavelengths. Now we need to compare their energies. And the energy, so wavelength of first radiation I am taking it as lambda 1. The second radiation's wavelength is taken as lambda 2. Better we can convert into meters, but by comparing, let us take both in same units. Okay? Now, first radiation's energy E1, second radiation's energy E2 I am taking. Yesterday I given a formula regarding the E1 by E2. Okay? What formula given yesterday? Energy and wavelength are inversely proportional. So E1 by E2 is nothing but lambda 2 by lambda 1. Okay? E1 by E2 is equals to lambda 2 by lambda 1 because energy and wavelength are inversely proportional. Then substitute the values in the formula. E1 by E2 is equals to lambda 2 value how much given? 200 nanometer. Lambda 1 value they given as 600 nanometer. Okay? Lambda 2 is 200, lambda 1 is 600. How much it is? 3 times. So E1 by E2 is equals to 1 by 3 or E2 is 3 times of E1. Okay? Got it? Cross multiplication I did. So E2 is 3 times of E1. Okay? So this way we can compare. Or simply by looking at the radiation only we will come to know wavelengths. Wavelength of second one is less. Nothing but energy of this second radiation is bigger than first one. How many times it is bigger means it is 3 times bigger than or higher than the first one. Okay? Coming to the next question. The photon the wavelength of photon absorbed by the body is the wavelength of the photon absorbed by the body is 200 nanometer. Okay? After absorbing the radiation, it emitted two radiations. radiation of a particular wavelength, and the wavelength of the absorbed radiation is given. But after absorbing the photon, it emitted two photons, two radiations it emitted. The wavelength of first radiation is 600 nanometer. Okay, the wavelength of first radiation is 600 nanometer. Then what is the wavelength of second radiation? Okay, the wavelength of first radiation was given. Out of the two, the wavelength of one radiation is given as 600 nanometer, but they are asking to find the wavelength of second radiation. Okay, regarding these type of questions, what formula we are using, everything we discussed yesterday. Okay, because the energy required for jumping to higher level, okay, or the energy absorbed is same as the energy emitted. Okay, so based on that one formula given to you. What is the formula given? 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. Or after doing multiplications and the final formula what we are going to use in the questions is lambda is equals to lambda 1 into lambda 2 divided by lambda 1 plus lambda 2. Okay, right? Lambda 1 value given, lambda value given, but we need to find the lambda 2 value. Lambda value how much given? 200 nanometers. Lambda 1 value is 600 nanometers. Okay, we need to find the lambda 2. Okay, this one we need to find. Now let us substitute in the formula. Lambda is equals to how much? 200. Okay, lambda 1 value 600. Lambda 2 we don't know, divided by lambda 1 plus lambda 2. Lambda 1 how much? We got the lambda 1 value as 600 plus lambda. Okay, now we know 200 will be cancelled here 3 times, right? Now let us bring this term to this side. So 600 plus lambda 2 is nothing but 3 lambda 2. When lambda 2 we have taken that side, it will become how much? 600 is equals to 3 lambda 2 minus lambda 2. How much it is? So 2 lambda 2 is equals to 600. Got it? 2 cancel here 300 times. So lambda 2 we got finally as 300 nanometer. Okay? Understood the question how we solve? Or when we are applying this formula, when the light, when the any body or the electron, when it absorbed one radiation and when it emitted two radiations. Okay? Out of the two radiations, wavelength of one radiation is given and asking to find wavelength of other radiation. Okay? So this is the formula we need to remember to solve this. After taking the LCM and the final formula is lambda 1 into lambda 2 by lambda 1 plus lambda. The finally absorbed wavelength is given as 200 nanometer. Emitted one radiation is 600, other radiation we need to find. Okay? So then these normal calculations you already know. It is easy one to solve. So finally we got wavelength of second radiation as 300 nanometers. Okay? Note down this one. Now, coming to the next model question. For example, so go to the question. Calculate the energy of radiation whose wavelength is 123 nanometers. Okay? Calculate the energy of radiation whose wavelength is 123 nanometers. Here, okay, we know how to solve. I think first model question we solved in the same manner. How to solve this question? First of all, wavelength is given as 123 nanometers they given. Okay? So we need to convert this in terms of meters. So 123 into 10 to the power minus 9 meters we are putting. Okay? Right? Now, before going to do all these things, let us write the formula. Formula is what? E is equals to hc by lambda. Okay? H value we know, C value we know, it is always constants. So, in these type of questions, if they give the options in terms of electron volts, I will give you a shortcut form to solve the questions fast. Okay? How to solve means, remember, here, E is equals to 12375 by lambda. This is in terms of electron volts. Okay? Instead of doing all the calculations, simply you can remember this formula. Okay? Because already I explained the first question using that formula. If you take the H value in terms of joules, we will get the answer in terms of joules. If the options are there in terms of electron volts, better directly you use this formula. Okay? So, when we are going to use this formula means energy is in electron volts and the wavelength should be in terms of angstroms. Okay? Remember that. This value, this formula 12375 by lambda, we are going to use when the energy they are asking in terms of electron volts and when they give wavelength in terms of angstroms. Okay? It is not a problem because whatever the value they give in terms of angstroms, we know how to convert it into angstroms. Okay? For example, in the above question they given in nanometers. You know how to find angstroms. Okay? Because 1 nanometer is nothing but 10 angstroms. Okay? So directly we can substitute in the formula. Or even to make the question easy. And directly I am going to give the value in terms of angstroms. Okay, even better, let us take the cancellation point of view. I am taking in terms of angstroms. Okay, let it be in the question they given this value, right? And we know when they give in meters, 1 angstroms means 10 to the power minus 10 meters. If they give the value in meters, you know how to convert it into angstroms, means divided by 10 to the power minus 10. Okay? Nanometers, 1 nanometer means 10 angstroms. We can get the value. So, instead of substituting H value and instead of substituting C value, then lambda, then instead of doing that much big calculations, in a simple way, shortcut way, remember this one. But we need to use this formula when they are asking the energy in terms of electron volts. Okay? So it is simply E is equals to 12375 divided by lambda is given in the question as 1237. Okay, so will be how many times? Approximately 10 times. Got it or not? So we will get approximately 10 electron volts. Okay. So for example, instead of electron volts, if they ask in joules, we know how to convert electron volts to joules, right? So note down this one. Now, coming to the simple topic, that is black body radiation. Okay, we all know about this one, black body radiation. So first of all, what is meant by black body? So remember this. Black body is nothing but, in a simple words we can say that a black body is nothing but it is a perfect emitter as well as it is a perfect absorber. Emitter means we know it emits the radiation, absorber means it absorbs the radiation. But why we are using this word perfect emitter or perfect absorber means? Because a black body can emit all types of radiation. Means radiations of different frequencies or wavelengths, as well as it can absorb the radiations of different wavelengths or all types of wavelengths. Okay. A simple example to understand this one. Generally we know, if you observe the bulb, how bulb will glow? Because there will be a metal filament will be there. When electricity is passed, the filament will become hot. When it becomes hot, then it emits a radiation. Okay? So we know from the bulb a white radiation will come. And everyone knows that the white light is composed of different wavelengths. Okay? So when a metal body is heated to high temperature, then it emits radiations of different wavelengths or different energy. Because even one more example, if you see, to understand this concept is, we know any metal strip, when it is heated, iron rod when heated, it appears in red color. Okay, that's why we will say generally as a red hot condition. Okay. So when iron rod is heated to high temperature, it will be appears in red color. Okay. Even from that state, if you heat even to the high temperature, slowly this red colored one will be changes to yellow color. Even when goes to very high temperature, it becomes white color also. Okay. Why it is changing from red to white means, the red color means because corresponding energy. We know red color will have lowest energy, yellow color will have high energy. Okay. So based on heating, it is emitting different radiations. Means the radiations are different wavelengths. Okay. When the metal body is heated to high temperature, the body emits different radiations. Nothing but the radiations of different energy. But coming to the black body, the black body means it emits all types of radiations. The radiations of all types of wavelengths. It can absorb as well as it can emit. Okay. So such type of body is known as black body, and the radiation is known as black body radiation. Okay. Note down what is meant by black body. When a metal, first note down the definition for black body. No need to write anything. commutative point of view, what is meant by black body we need to know. Black body emits or absorbs the radiation of different energies. Okay? A black body can emits or absorbs the radiation of different energies or different frequency or wavelength. Okay? Because energy is different means automatically wavelength and frequency also different. So we can define in any manner. But in a simple words, if we want to say a black body is nothing but it is a perfect emitter or perfect absorber. But it can emit or absorbs all types of radiation. Okay? Now coming to this weekend, you will have examination for weekend is mainly the last week whatever we discussed about electromagnetic radiation. Okay? For weekend syllabus, electromagnetic radiation, types of electromagnetic radiation including with Planck's quantum theory and black body. Okay, the questions mainly on Planck's quantum theory as well as electromagnetic radiation types and then characteristics, wavelength, frequency, everything. Okay, thank you.